Chris Morrissey, Bosch Home Comfort Factory Technical Trainer from the Southeast region.
And Chris Penn, Factory Trainer from the Great Pacific Northwest. Today we're here with Bob Jr. to talk about the importance of airflow and how it affects our Bosch IDS system. So Chris, tell me what makes an IDS system unique in the heat pump and AC market.
Okay, a Bosch IDS system is a load matching inverter-driven heat pump. We have a Bosch rotary compressor that modulates in 85 different steps in 1% increments.
Okay, so we're talking about this inverter technology, but you also mentioned load matching. So tell me what load matching really means, because I think this is where people get lost.
Okay, when we're discussing load matching, what we're essentially referring to is the ability to adjust the capacity output of our outdoor unit to feed our indoor unit. So the compressor is essentially going to operate and use the indoor conditions. So if I have a house that's neutral in conditioning, it's only going to use what capacity it needs to deliver. When we have a single speed compressor, it's unable to detect hot, humid air introducing into the system. So it just runs. Consumes a lot of unnecessary power to deliver a capacity output that we no longer need. So when we have hot, humid air entering our house, we need to variate the capacity of the outdoor unit to match the indoor load. So we're going to take our system and ramp it up to feed more refrigerant to this system to make our coil colder to overcome the infiltration. As the infiltration is overcome, the system's going to back down and get to its happy spot.
So you mentioned changing coil temperature. So what actually causes a coil temperature to go up and down?
The airflow moving across the evaporator coil in the cooling mode is the most essential aspect of this system operating correctly.
So less airflow means less heat transfer. Less heat transfer means compressor ramps down, thus reducing BTU output.
Airflow is so critical, we don't realize, but it's been a problem in our industry the whole entire time as long as we've been installing equipment. The reason it's a problem now is the airflow is so critical of this system modulating up and down. Like I was saying about that fixed seat compressor, it did not know what was going on inside. This system now knows what's going on inside and it's going to modulate up and down. When we discuss part failures, one of the number one things that causes a part failure is the ductwork. The reason why is the system works harder and is stressing the compressor, stressing the fan motor to overcome whether it's static pressure, refrigerant charging issues.
So basically what I'm hearing you say is I can't install this system on existing ductwork. Do I got to make some changes to that ductwork? And if I don't, what's going to happen?
No, not necessarily, but the problem is ductwork has always been a problem in our industry, but we did not know it. It was a long-term effect. What I mean by long-term effect is it took 4 or 5 years for this fan motor to let loose under the stress.
Okay.
A year later, the compressor's grounded. We replaced the part thinking the part was the root cause of the problem.
But we didn't do anything with the ductwork.
We didn't do anything with the ductwork. That was not the root cause. The root cause of part failure is the application and the stress it's under.
So there might be some airflow setting adjustments that we might need to make as well. Is that what you're saying?
That's correct. No matter when we install an inverter system, we have got to shoot for 350 CFM per ton. If we do not achieve that, the system will not work correctly. One of the most common problems is overcharging a system with too much refrigerant. The reason that is when we have high static pressure from insufficient ductwork, large media filter cabinets, their airflow is reduced. When that airflow is reduced, our CFMs are reduced. We're not delivering the amount of air we need over this coil. That Bosch system recognizes it. My suction pressure drops, the system backs down.
Okay.
One of our number one issues with our tech support team is the call comes in, our system doesn't keep up. Not like our old system did.
Yeah.
So that the end user, the homeowner, wants to know, why does this new system not operate like my old system? And that is re-educating our contractors as well as our homeowners.
Okay.
Filters are one of the biggest things in our industry that are overlooked of being a problem.
So I just can't use any filter I want?
No, you certainly can't. The only time you can use any filter you want is when you prove your static pressure is within our Bosch blower performance data, proving this system can perform in the environment you installed it in.
Well, how about we see this in action?
Absolutely.
Let's put it to the test.
Yeah. Let's do an example where we operate our system, and what I would like to do is use a regular 1-inch filter, non-pleated.
Okay. So what kind of information are we going to need to perform this calculation?
We need really basic information, Chris. Every technician should have a static pressure manometer. What we're looking to do is get our supply static pressure and our return static pressure When we're checking return static, we want to be behind our filter. We need the pressure drop through our filter.
So I can't be in the other side of the filter.
No,
Otherwise, I'm not including it.
you're not
correct?
including the filter.
Okay.
That's right. So when we come behind the filter, we're getting our total static pressure. Most of our fan motors and our Bosch equipment will top out at 0.8 inches of water column. That's total supply and
max.
return. That's max. Anything over 0.8, our engineers have not designed a system to operate. It's outside of our engineering parameters.
So the higher the static, the less the airflow.
Yep. The less the airflow, according to a set of gauges, your suction pressure is now lower than it needs to be. Most technicians, when they see low suction pressure, they're going to add refrigerant. But they've overlooked one thing before they add that refrigerant. If they don't pull out their manometer and look at the static pressure, we're going to overcharge a system. The problem with overcharging a system is now we've lost our capacity.
Okay. So you mentioned static pressure. I needed to collect static pressure.
Yep.
Before we do this calculation, what are a couple other things that we need to collect?
Well, when we get our static pressure, we're going to go to a Bosch blower performance data chart, and we're going to prove at what static pressure, how many tons the blower motor is, how many CFMs are we delivering. And right now with inverter-driven technology, we want 350 CFM per ton. This is a 3-ton unit. I'm looking for 1,050 CFM
Okay.
to deliver to that.
Do we need supply air and return air temperature along with this calculation?
We sure do. We need our delta T across that coil. That delta T across the coil is proving the air we're bringing in and the air we're delivering to the space. We're looking for that industry standard 15 to 20 degrees, but there's a lot of variables that come into figure.
It could be as high as 22 or 25, I suppose.
It could be. This Bosch system actually could run as high as 30 in the right conditions
Yeah.
and then back down as that coil gets
Okay.
colder.
Okay, so we need supply and return air temperature for our calculation. We need static pressure. And once we have these, we can put them in a formula and do the math, right?
That's right. We're going to do
And this is going to give me BTU capacity.
We're going to do a BTU output capacitor. We're
Okay.
simply going to use a constant of 1.08. That's our air. We're going to use delta T. That's my supply difference, return and supply temperature.
Yep.
That can prove our coil is working correctly. And the most important thing, Chris, is we need the CFM. We got to have CFM. We can't guess. This is a 3-ton unit. You just can't guess it's 1,050 CFM because I told you that. You have to prove with your tools that this system in your duct system is in fact providing 1,050 CFM.
And the blower chart will help us get that. If we got that static pressure number, it's basically, in a lab setting, it's going to give me that CFM number or thereabouts, right?
That's correct. So like I said, I allude to the filters. We'll do our example here, but a 1-inch filter is really what we want. When we go to a media filter, 4-inch or 1-inch, right there alone is restriction on our air.
Yeah.
At 0.4 static pressure, this blower motor was moving what we wanted, 1,050 CFM. The homeowner removed this filter and they installed this filter. This is a pleated MERV 11 filter.
A little bit more restrictive.
Little more restrictive, it gets bigger particulates and dander. The problem is if you have ductwork designed in the 1990s, the 2000s, or even older, therein lies our problem. We had R22 duct systems designed for R22 ductwork.
A little bit more forgiving.
Chris, we're on our second refrigerant since then. We're
Yeah.
through 410A. We're into 454. In 454 refrigerant, still operates the same. We need the correct amount of air moving over our coil. These filters can be installed. You can even use a 4-inch filter, but you must design your ductwork accordingly. So in this example, what we have proved is a regular 1-inch filter is not restrictive and we are complying with Bosch engineer specifications. Whether you install this or the homeowner installs this, this alone has now taken the capacity of your system outside of the range.
Wow, that's huge.
Static pressure, manometers, every technician needs to have one. On service calls, we need to be checking them, but when we're installing new high efficiency equipment, we took out a 10 SEER, we're putting in an 18, 19, 20 SEER piece of equipment. A lot has changed in our industry. If we continue to overlook ductwork and static pressure, we're starting out behind the 8-ball. So remember, improper airflow can be detrimental to the Bosch system's heat pump's performance.
So don't let bad airflow get you down.